Welcome back to Tech Sensei, Priya.
Great to be here, Raman.
Let's discuss Agentic AI.
It is the future.
Agentic AI, well, it actually buys the flights, books the hotel, and emails your boss to say you are taking PTO.
Yeah, exactly. So today, our deep dive into your sources is entirely focused on this massive shift.
Yeah.
We are exploring exactly how these autonomous AI agents are built, and how they are radically transforming real-world workflows for you.
We are really moving from AI as a passive oracle that just answers questions to a proactive partner that pursues a goal until it is finished.
I mean, the way I think about it, generative AI is like a brilliant consultant sitting in a locked room just passing notes under the door.
Yeah.
Agentic AI is giving that same consultant a badge, a laptop, and a company credit card.
That is a great analogy. To understand how they actually take action like that, we have to look past just the underlying language model. The LLM is really just the reasoning brain.
Right. It obviously needs more than just a brain to act in the world.
Exactly. To actually build an agent, you need three other core components. First up, you have tools. These are the hands that let it search the live web, execute Python code, or, query a private database.
Wow, okay. And the second component?
Second is memory. This usually relies on vector databases.
Oh yeah, vector databases. And instead of just saving a giant text file, a vector database maps memories as coordinates in space, right?
Yeah, exactly. So the agent isn't just searching for an exact keyword. It can conceptually feel out past decisions that are mathematically similar to the current problem.
That is wild. It's like giving the AI intuition.
It really is. And that conceptual mapping allows the agent to recall context over long periods, which feeds directly into the fourth component, orchestration.
Orchestration. So how does that work in practice?
Well, instead of a one-and-done prompt, the agent runs a continuous observe, plan, act loop. It looks at a goal, plans a step, uses a tool, observes the result, and loops back to decide its next move.
Wait, but if it is running its own loop, equipped with tools and a memory, what stops it from spiraling?
That is the big question.
I mean, if an agent hallucinates that a file is named A instead of B and writes that into its long-term memory, won't every subsequent loop confidently use the wrong file path until the whole system just crashes?
Yeah, that is called memory poisoning. And along with tool misuse, it's a massive risk. It's exactly why production-grade guardrails are completely non-negotiable.
So how do developers actually build those guardrails?
They use a layered approach to tame the machine. First, single responsibility agents. You don't build one godlike AI, right? You keep tasks narrow.
Oh, I see. So one agent searches and another writes.
Precisely. Then you use containerized deployments, like Docker.
So you trap the agent in an isolated virtual sandbox? Even if it goes rogue, you can only blow up the sandbox, not your actual computer.
That is the idea. Then there is the Model Context Protocol, or MCP. This acts as a standardized, secure bridge.
A bridge between the agent and its tools.
Yes, exactly. It defined exactly how the agent is allowed to talk to external tools, preventing it from executing random destructive commands.
That makes a lot of sense.
And to manage the rules themselves, developers use prompt decoupling. They store the agent's instructions and constraints externally, not hard-coded into the core system.
Wait, if you are keeping the rules external, doesn't that introduce latency? Like every time the agent wants to take a step, it has to phone home to check the rulebook.
It does add a slight overhead, sure, but the trade-off is stability. It lets engineers update safety constraints on the fly without having to take down and rebuild the entire system every time an agent finds a loophole.
So because these agents are trapped in those Docker sandboxes and governed by MCP, they can be given immense power in the real world without destroying our systems.
Exactly, which explains why your sources highlight these insane 10x productivity leaps in complex tasks.
10x. That is huge. What does that actually look like in practice?
The real-world applications are staggering. Take a podcasting pipeline. There are automated workflows right now where agents autonomously scrape the web for news, filter topics, and write the script.
By passing it between specialized agents, right? Like we just talked about.
Yes, exactly. Then they generate the audio and video and publish the final file to GitHub, all autonomously.
That is unbelievable. And think about the last time you spent 4 hours debugging a broken dependency in your code. Agents aren't just handing you Stack Overflow links anymore.
No, they're doing the actual work. In software engineering, they are opening the terminal, investigating the bug, applying the fix, running the test suite to prove it worked, and handing you the finished product.
Wow. And what about fields outside of coding?
Even in customer service, they are moving past basic chatbots. These agents log into the backend and proactively resolve complex account issues.
Like issuing refunds or changing routing tables.
Exactly, without a human ever stepping in. They are steering the whole vehicle while we just set the GPS.
It fundamentally changes software from a tool you wield into a colleague you manage.
Yeah.
But looking at where this is heading leaves us with one incredibly wild thought.
Oh yeah, what is that?
If these autonomous agents are already capable of writing code, testing it, and debugging software on their own, what happens the day an agent is assigned the goal of building a smarter version of itself?